Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are just in the middle of doing some modifications to the way we're handling Z in the engine, and we sort of stopped the stream last week at a point where I was like, I would like to stop having to have all sprites on the screen be sorted through the same sort path. I would like to basically have them split up into like tranches, basically, where we've got sort of layers that are handled separately, and each layer is then sorted through the sorting system. So in order to do that, what we will have to do is we kind of have to come up with some clever ways of making it so that the code that's actually sending the stuff down to the renderer doesn't have to do a ton of work to do this segregation, right? Because what we don't want to do is we don't want to make it so that there's a ton of work that goes into having to figure out how to parse all these things out. We want to make that as easy as possible. And so there's a number of ways that cross my mind as to how to do it. We talked about one at the end of last stream, but probably what I want to do right now is just briefly talk about the situation and sort of discuss what we can do to make it work. So essentially, here is our problem. And I'm going to move down to a new thing here. Today is day 315. Oh. I don't know why, but for some reason Milton always ends up thinking we have a mouse after a while. I think it's got some kind of a bug there. Not sure what it is exactly. All right. Oops. Day 315. So layered sorting. So we have a couple different ways that this could go, but I just wanted to sort of explain a little bit about what I mean and why this is sort of something that there's a lot of ways we could do it, and we probably only want to do it in one specific way once we figure out like what's going to be the most natural, right? But we don't. It's hard to know necessarily a priori which is going to be the best. So if we think about what's happening here, we have a set of entities. And we've got a lot of them. I guess I should say entities. We've got a lot of them, and we don't necessarily know anything about them at the outset, right? We don't even necessarily know how much stuff they're going to draw. All we have is a giant array, and each entity maybe has some components to it. You know, an entity can have more than one sprite associated with it. And what we want to do is we want to go from this over to the other sort of representation of it inside the render, which is per layer, right? So we want like a layer, 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 and inside here we want the sprites that are part of the layer. So the problem is, first of all, if this were completely heterogeneous in terms of where the layers go, then this would kind of be a swizzling sort of situation, right? We would end up having stuff that kind of goes like this sort of a thing, right? Who knows what's going on. But we would sort of have all these sort of crosswise, like, oh, okay, every single entity is going to get mapped to a specific layer, and there's no real coherence between them and whatever. However, if there is order to our entities, then it's possible that that doesn't necessarily have to happen, right? It's possible that if there is order to the entities, then what we could actually do is just sort of use the order of the entities in here to imply where they go and make things a little simpler, right? So those are two separate scenarios, and let me tell you why we don't necessarily even know which one we have. So if we didn't have any idea how the entities were ordered in the list, then we would have to say, well, it's definitely going to be this kind of swizzle sort of scenario. But keep in mind how we got the entity list in the first place. The way we got the entity list is we actually did a walk through our spatial data structure for storing the entities, and we actually walked through a 3D sort of cubic, I don't know what you want to call it, almost like a voxels, right? It was basically like a gridded spatial partition in 3D. And we had something that looked like this. And during that call to begin sim, if you remember, we walk through this list and we grab all the entities out of here, the entities out of here, 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 whatever, right? So what this means is that when we built this entity list in the first place, it was actually already sorted by layer when we grabbed it. Because we started with the bottom Z layer, or even if we didn't, we could decide to start with the bottom Z layer, then the next Z layer, then the next Z layer, right? So we can actually assume that these are Z layer sorted in the first place, right? When we initially unpack them, when they come out of begin sim, we know they're already in order. Here's the problem. We then go ahead and move them, right? Because all the entities then get simulated. And 99.9999999% of the time, they are all going to still be on the same Z layer that they started on, right? Because most of the time in a 2D game like this, people are moving around in a room, or not moving around at all, like all the trees are just stationary, right? So most of the time, whatever your Z layer was coming out of begin sim, so too will your Z layer be going into end sim. And so if we wanted to use the order that was implied by the entity list, we would know that that order is generally the same throughout the entire sim process. So we could just do something where we just go, okay, spin through the list until we get to the first person who's on a new Z layer, then we spin through the list for that Z layer and so on, and just it's segmented that way. But the caveat there is, like I just said, you end up with a problem, which is that people may have changed their Z layer. So some people may have been simulating and they're just on the edge and they're about to transition from one Z layer to another. During this sim step, they make that transition and now they're in a different Z layer than they used to be in. And in that case, we would now be putting them in the wrong layer for one frame. On the next frame, they'd be in the correct layer, right? Because they're going to get packed back into the spatial partition, and then at that point, you know, everything's fine. So that's the situation that we're in. And what that means is we can either do one of two things. We have a decision to make. Either we can leave everyone in the Z layer that they were in when they got unpacked in begin sim and not have to do any work to sort people into layers, but we would have one frame of lag in updating the apparent Z layer of each entity during transitions. Or we can not do that and have some separate system that does the sorting post facto to resolve those Z layer problems. That's the choices. Now we could do a slightly more hybridized scheme. And what that would look like is, suppose that we took the entity list and we started sorting the entity list to produce an entity list that was sorted by Z layer. Well, instead of doing something crazy like a merge sort or something like this, which would be a full-on, you know, just like we had over here, a full-on sort that would take time and, you know, temporary space or who knows what, we could leverage the fact that we know that very few entities will change their position in this list and actually just use like a bubble sort, a very, very simple bubble sort. And it wouldn't even really be a bubble sort. It would be more like a push-down sort. So basically what would happen is, you know, we would sweep through the list, and any entities that were on the wrong Z layer, we would pick them up into a side buffer or something, right? And then place them back down and swapping out people who were at the beginning of the new Z layer list or something like this, right? So we could write a specialized sort that would sort of fix it up. And what I think, my assumption, so I'm talking all this out with you so that you can see what my thought process is, and hopefully it makes some sense. My assumption is the right decision here is to say, well, we don't even know if we care whether we have one frame of lag in Z layer updating. And it seems like we could write a special purpose sort that was very fast to fix up the entity list in the case where we do know that that has happened and we care. So maybe what I would suggest is let's start by just using the entity list as is and using the original Z layer of each entity. And then if we find we are having visual bugs that result from this, then we will go and write a sort that operates on that entity list post facto to do the fix-up. How's that sound? All right. So that's what I'm going to do. No mystery to it, right? That's all there really is to say. I'm going to go ahead and get started. Today is day 315, so again, if you're trying to follow along at home, you will want to unpack day 314 source code into a directory. That's the directory, I'm sorry, that's the source code version that I am starting on. So yeah, do that. So yeah, as I was saying at the end of last time stream, if we do want to approach this the scheme this way, which I think we do, then we do need some additional information in the render system. And we sort of, wow, typing is hard. We added it at the end of last week's stream, I think. At least that's my recollection. And if I remember correctly, what we did is we set a little token in the stream that would basically let the sorter know, hey, you've reached a barrier, so sort these guys, but you don't have to sort anybody else, right? You don't have to sort them with anyone else. So sort all these guys, and then next time sort the next batch, and next time sort the next batch. So we already now have a way of inserting those sprite barriers. So what I think we can now do is when we have our game render, what we should be able to do in the entity code that actually outputs this stuff is, first of all, I guess we need to go into sim region and just make sure that everyone actually is coming out in that order, right? Because the loop where we loop through, where is that at? Well, let me just search for begin sim. We want to make sure we're going by Z. And if we look here, it turns out our loop is already exactly in the order that we want. It just happens that way. You know, we don't have to reorganize it. You can see that we're going by min chunk Z first, and then we're going up in Z. So that's perfect. That means all of the minimum Z entities will be grabbed first, then the next tier entities, the next tier entities, up and up and up. So we should have then an entity list that's perfectly in order, the exact way that we wanted it to be. And so all we really need to do now is insert those barriers when we're actually doing the rendering. So when we come through here and we actually are in the entity unpacked entity list doing the rendering, what we should be able to do is now say, all right, before, you know, I was sort of doing this map into chunk space thing, finding out what the Z layer is of a particular entity, I don't actually want to do that anymore. What I want to do is just look back at the old world position of the entity, right? I want to look at the entity as if it had not been moved yet. I want to look at its old position, just for purposes of figuring out what the layer is. Because like I said, we're using last frame's position, right? So in doing so, I want to look in here to see where it's actually placed. I assume that that is stored in here somewhere, but I don't actually know. Let's take a look. We should have a world position somewhere, shouldn't we? Okay. I guess we don't actually store that. I'm not sure why we don't persist it. I guess maybe because we don't need to persist it. I'm not really sure. But I guess that's fine. So either way, I'm going to go ahead and put that in here. I guess all we need to store really is the Z layer. So I'll just store Z layer like so. And all we have to do now is when we do that unpack, I can update that Z layer. So inside the sim region, when we unpack here, it's really just that chunk Z that I want to know. So when we unpack one of these guys, doing this sort of pack, when we do the sort of the clearing and that sort of stuff here, I guess I'll just do it like this. I'll just say that the Z layer is going to be whatever the chunk Z is here. So now everyone's tagged with which one they are. And then when we come through here, we could just say, well, okay, when we're going through these entities, I just know that I need to insert that token, basically, that thing that says, hey, you need to break the group here. I just need to do that periodically to let the system know what's going on. All right, so let's do that. So first of all, I'm going to need I'm going to basically need a piece of information that's a running knowledge of what the z-index actually should be. So what I'm going to do here is I'm going to say, all right, I've got an S32 that's like the current z layer. And that current z layer is going to be, and I guess I'll say current absolute z layer just so we're clear on what that actually means. I don't mean one of these things here. So we have a current absolute z layer, and that current absolute z layer is just going to be, if we have any entities at all, it's just going to be whatever the first one of those is, right? So assuming that there is an entity count of any kind, because if there's not, we could just say it's 0 because we're not going to output anything anyway. So if there is an entity count of any kind, then really all I want to do is just grab whatever the first one is, and that's the z layer that we're going to start on. So, you know, whatever that is what we'll start with. Then from then on, all we're going to do is we're just going to update the z layer every time we output one of these entities to make sure that we know whether we moved to a new one or not, right? So in here, this chunk z stuff, now we can also pull. We'll be able to get rid of that, which is good. Like I said, I want to kind of pare that down. So we kind of just shove that into the system. We should be able to sort of pare that down now. Let's go ahead though and finish what we're doing here before we embark on that. So we have the current absolute z layer. What we want to say is if the current absolute z layer is not gonna match. So if we were about to render somebody in a layer that isn't their layer, first of all, we could assert that we're always monotonically increasing. So we could say, like, let's assert that we're going up in z because we know that we need to sort of put them in slices that go higher and higher and higher. So we'll assert that that's true, but assuming that that actually is true, then what we want to do is say, all right, let's then co-opt this new z layer as the z layer that we're working on, and we want to then insert we then want to insert a what's the word I'm looking for? That sort of barrier. That's what I was using. We want to insert that sort barrier that lets it know. So while I'm doing that, let's go ahead and fix a few of these things here. The entity z layer, we don't need to do this stuff anymore. So in order to figure out the sort of relative z layer here, we can just do that subtract. We just take the z layer minus the chunk z because that's all we really wanted to know in the first place. So we can make that happen. That'll tell us the relative z layer. I also don't really know, yeah, we'll come back to that in a little bit, I suppose. But anyway, we then can get rid of this particular piece of information here. But either way, you know, I can preserve it for the time being if I wanted to by going like this. Once we have that information and we have relative layer, we know that only if the relative layer fits within our layers are we going to render anything. So really, if we want to, I think we can dispense with a little bit of this situation here. I can just move this inside, because we know we're not going to care about this stuff if we're not going to render the guy, right? So when we come in here, and I see it's different, I want to do this absolute layer thing, but then what I want to do is I want to insert a sort barrier, right? Or maybe I should keep our naming consistent and say push sort barrier to the render group. I want to be able to say, hey, this is a sort barrier. Go ahead and put in one of those special markers that you need to put in to make that stuff work. So back in the render group, we need that to actually happen. And so where I've got push render element, I believe, we'd also have another one here that's, you know, a push sort barrier that takes the render group. And all that's going to do is it's just going to do exactly this operation here, right? And since that operation is relatively simple, I'm just going to copy it because we don't care about a lot of this stuff, right? So when I copy it, if we do this, we really don't need the entry to be anything other than that special marker, right? We don't need any of this stuff at all. We can just say that the entry offset needs to be whatever the sort barrier key actually was, oops, which is in here somewhere, Sprite Barrier offset value, right? So if we push a sort barrier, that's really all we have to do is do this push. But we have to make sure that we could actually push it, right? We do need to actually be able to push it on there. So we still need to check in here that we would not be advancing past the place where we could legally do it. Make sense? But that's it. That's all we really need to do for that. There we go. All right. So that's the basic idea. Now we actually have to make this go and actually work, right? I don't know if we really got around to finishing this code, so I actually want to go inspect that. This is the code that actually has to do something with this. I don't know that I actually did this particularly correctly, so I want to actually take a second and make sure that we've actually got this code correct. All right, so inside build sprite graph, now what we're doing is saying let's take a starting value, and what we do is we start at that starting value and then we go forward to the node count, incrementing by 1 each time, unless we get to the part where we encounter the sprite barrier offset value. If we do encounter the sprite barrier offset value, we're going to break. Now, there's a problem with this, which is that then we return that node index A. I think we don't increment it after, so really, I think what we technically want to do here, that's actually not quite correct. What we technically want to do here is say, okay, when we hit the offset value, we actually still want to do the increment. We want to break like after the increment, essentially. So that's a little bit more correct there. And similarly, if we don't initialize the flags value, which we know we wouldn't in the case of sort barrier, we can't assert on that because it's going to be garbage, right? So that's a little bit more correct. Down here, when we do our sorting and so on, you can see we start with the first index of 0, and then we're just using that return value, and we never increment it here. And that's the crucial part. So it has to come back pointing to the next valid person so it can start again. But I think otherwise the code is mostly right. So let's go ahead and start the debugging process as we go. All right. So first off, we're getting an assertion on the flags value not being cleared properly. And so I'm not sure exactly why that's happening. Let's take a look at what we get there. And essentially that means, this value that we're looking at, right, is not a sprite barrier value, right? Because you can see that its offset is not set to like FFFFFFFF. So what I might want to do just briefly is I want to see what node index A is, 233. I want to see what the input nodes actually are in this case. And I want to see, let's take a look here, hexadecimal display. Yeah, so that's actually, it looks like it's just something that has been processed already. So what I want to do here is say, okay, let's take a look at input nodes plus 232, right? Let's look at the previous one. So you can see that the bug happened exactly where we might think it would happen, right? It happened right after we processed one of the sort barriers. So I clearly just, well, I don't clearly just have anything. My mental assumption, right, that I'm making during this debugging process is like, I expect to have a problem near the new code. This looks like I'm having a problem near the new code. So let's take a look at what actually happens there, okay? When we hit that barrier offset, we increment the node index to the next value, and then we break out of here, right? So when we come back in and we start again, we're going to be starting with one that's one after the one that we are on, right? So in theory, its A shouldn't have had any flag set because we shouldn't ever have touched it, right? And we shouldn't ever have done anything with it because we never would have checked anyone out past there. That's the assumption anyway. Clearly that assumption is wrong, or there's a more straightforward bug in the code, but that's, that was sort of the thinking behind that particular piece of code, right? And so in here, looking at the way this works, it looks like that should have been the case. Oh. But you know what? We have a separate bug here, which is that this is not the correct, neither of these two things are correct. So walk sprite graph is kind of busted at the moment. Let's fix that first before we do any further debugging. All right. So what's happening here, right, is we sort of have a notion of whatever the first index is. We then pass a count here, but really this is going to give us back, you might say, last index, right? It's giving us back whatever the index is that we would do after, and now that I think about it, this is probably something where I'm going to want to not increment this, because in the case when I've actually hit the node count, I want to know that, and that'd be a little bit easier to do here. All right. So anyway, what we do is we'd hit the last index. We know that whatever that one is that we're on was the last is... No. Wait, I'm lying. I'm fine. I overreacted. I overreacted there. It's okay. So this is really one past the last index, right? So if I get one of these and I'm building the sprite graph here, I know that I'm going to have to compute a new count, right? I need my one past last index minus my first index to be this is how many of the things I need to process, right? And so I need to pass a different count here. So I need like a sub count. And I know where to start because I obviously know that the first index, entries plus first index, is the base of the array, and I know the sub count. But there's a subtlety here, right? And the subtlety is I get back this one past last index. It might be the actual one past last index, and this might be valid. Or it might not be, because it might be that the count is now including the sort barrier. And I don't want it to include the sort barrier, because I don't want to actually draw or process the sort barrier at all. So what I want to do here is say, well, if one past last index is less than the count, then the sub count should be subtracted, right? I should decrement by a little. And the first index should be advanced, right? But before I do that, oh no, it doesn't. I'm sorry. I don't have to do that yet. I don't have to do that anymore. Never mind. That was if I was doing it the other way. The sub count should be decremented to not include the sort barrier. Then at the end, all I really have to do is say, okay, now I want to advance my first index to be wherever my one past last index was, and that should be okay. So now at least we're not calling walk sprite graph with the totally wrong information, and we should be able to get a little further in the debugging process. Okay. I don't really know what this is talking about here. Add edge front equals add index. Yeah, we gotta step through this and actually see what we're doing here. Let's stop that and go to here. Okay. So we call build sprite graph the first time, and we get back, a first index. We're going to have a first index of 0, obviously, and we're going to have a one past last index, I think, of 233, right? And so since that's less than the count, that means that our sub count is actually just going to be 232, right? That's how many we're doing, because we don't want to process that last value. So we're going to process, oh, hi. Yet another bug I already saw. So this count value, right, also has to be adjusted here. So all that stuff also has to be adjusted. Hopefully that makes sense. Anyway, like I said, we go through here, and we're going to pass, the standard count in entries the first time through. We're going to compute how many there are. We're then going to pass sort of the offsetted array and the sub count, which is 232. We're then going to update this index to point 233, and we're going to repeat the process, right? This time through, we're going to actually change the count and the entries to here. So we're going to start at 232 and go only 201 forwards, and we're having an offset input nodes, right? So we're going to go ahead and process all those guys. Oops, I didn't mean to actually change that file. I hope I didn't. And then we're going to do exactly the same thing, walk the sprite graph again, and so on and so forth, right? Okay. So it looks like here, walk input nodes. It looks like here we are still... Okay, so yeah, we got... yeah, this is one of those little nasty situations. So we also still have one problem, which is that all of our indices are based on the wrong things, potentially, I guess. I'm trying to think if there's any places where this actually comes into play. But when we talk about NoteIndex A, really, I guess we don't want to do it quite the way we were doing it. Because since all of our indices have to be based on the group, we don't want this NoteIndex A to be absolute, right? We want this NoteIndex A to be relative. So I think we actually want to do it this way. And then we want to just be able to return whatever that count actually is, like however many we actually did. So I'm going to take it back. I'm going to say this is the way we would do it. We wouldn't pass this in. We would just say, okay, let's pretend you just handed me a group. I'm going to do it like I did it, and then return you the count of things I actually processed, right? Then I can make this code a little bit cleaner here so it doesn't have to think quite in that same way and have sort of the weird thing. It's everyone's indices are based off of a standard basis, right? I can then say sort sprite bound like subentries is going to be equal to entries plus first index. And then I can say, well, all right, then call it and get the sub count, because that's what I'm going to get here. I don't have to pass this first index anymore. I know that's just sort of what I'm keeping track of. So I go ahead and I say entries plus first index. I get the sub count by saying, okay, what, do the build sprite graph operation, subtract from the total count wherever we were in the first index, add to the entry. So we're basically creating a new slice of that array, or just pointing to a new slice of it. And then what we want to do is say, well, the sub count is just what we return directly, but we still want to say if that sub count, I guess if the first index plus sub count wouldn't have hit the end, we might want to do the adjustment. But I don't know if we actually need to do that. Let's take a look at how that's going to work. So when we come through here, and I'm going to say we're going to break with our node index A, sort of pointing at the right place. So really this count will always be correct. The only question is, do we need to advance afterwards, right? And I think that that's pretty straightforward. We just say the first index is equal to, it adds the sub count plus 1. So it's always going to move by however many we processed, and then also skip the barrier. If there is no barrier, because this is the very end, it's okay, because it'll just be a little higher than count. It'll be 1 over where it should have been, but that'll still terminate the loop, right? So I think we can make this a little simpler here by just saying okay. Then we've got almost everything in a pretty condensed fashion, and that is just looks a little less error prone, a little more clean to me. So okay, so now let's try that, and let's see, start the debugging from there, because I think that's a little bit better. Excuse me. All right, so we've got a bogus clip breaking index here. That just suggests that we probably have a bogus offset. Yeah. Excuse me. So what I'm assuming happens there, and I think this is probably actually pretty self-evident. So, yeah. So we have one more thing we kind of need to deal with, which is that the push buffer element count, if we take a look at what happens here, when we push the sort barrier, we need to increment the push buffer element count forwards. But at the end, we won't actually have that many push buffer elements. You know what I'm saying? So I'm not sure exactly where we're getting that when we output our things we're trying to output. I'm not sure who decides how many to draw. But I assume that what we would need to do here is say, well, since we're only outputting things in the walk sprite graph, since we're only outputting things sort of periodically there, and the out index array needs to get advanced, right? Because we've got sort of the, when we call walk sprite graph, we're passing this array that's got this many elements in it, but it's only going to end up with that many minus the number of times we did this loop, right? So essentially, we need to modify this value for every time through the loop that we go extra. We're going to have less of these. So I think what I need to do instead is say something like, okay, reset this push buffer element count. Say, okay, that's going to be equal to 0. And then when we write things out here, we're going to have to increment it like each time or something like that, if that makes sense. Hopefully it does. You can see when we come through here, we've got sort of this idea of the out index, right, at the out index array. And that now kind of needs to be something that's going to be a little bit more sort of proactive. And in fact, I might say, let's just get rid of the walk sprite graph thing altogether. Let's actually put that maybe in here and say, all right, in that case, we know we've got sort of this input nodes basis. We want the out index array to be something that's kind of more persistent. like so. And what we want to do here is say every time through this loop, we're going to set the input nodes to the sub-entries, and then we're going to actually do this loop itself right in here. Oops. Ah, there we go. Excuse me. So in here, we're going to start. We're going to say, okay, these are the input nodes that we have, and now we're saying, so that walk, sprite graph walk, we got the input nodes, the output, and the hit cycle. We're going to restart the hit cycle part, and we're going to set the input nodes to the base array, but we're going to leave the out index there because that's kind of streaming pointer that wants to keep incrementing as we put stuff out. Every time we put one of those things out, we want to increment how many there are. Now, we don't actually have to do that manually. What we could do instead is just at the end say, well, okay, wherever the walk's out index is relative to the base pointer, that's how many elements there were, right? So it's more like just saying, oh, hey, this is how many there are, and this is like change the total number of things to reflect how many there are without barriers. It's like doctors without barriers, you know what I'm saying? So in here when we do our walkthrough, the indices, now we're just going to say go through however many there are in the sub count and output them that way. All right, that's not a arrow, that's a dot. And can't convert from int through 2. Okay, we know that there's never going to be that many sprites, so I'm comfortable casting down. We're not going to have 4 billion sprites. Heaven help us. I don't think our code is up to it at the moment. So anyway, here we go. And now we're actually running, so that's good. But we don't really know what we're doing, right? We are running, but we don't know for sure whether we're actually, whether any of the sorting is actually happening, right? And you can see that it doesn't appear to really be doing stuff right per se, because like that top layer is sorting below the layer that we're on, which doesn't really make a whole lot of sense, right? So we're still a little bit wonky, but we're at least getting there. We're starting. Okay. So let's start by saying, what do we want to do here with, think of where I want it, because there's two separate things that can be wrong here, right? Wrong here, right? That's good. There's two separate things that could be problematic. One thing that could be problematic is the relative layer that we're actually going to be setting down, or the sort barrier kind of stuff that we're doing could be wrong. So we could be sending down wrong information. That's one thing we could be doing. The other thing that we could be doing is we could be making it so that our sort is somehow not dumping these things out correctly after we do them, right? So, which one is it? First one I want to do is I'm going to step in a little bit to the entity list stuff, and I want to take a look at what's actually happening when we actually push these barriers on, because I don't really have any insight into that at the moment, and I would like to get some. So let's take a look at the entity index that we're on, number 202. So there's 200 entities before we change layers, which isn't quite commensurate with what we were seeing, because I thought 233 was where it started before. It's a little weird, but whatever. Hear me. And then we've got the current absolute Z layer. I want to look at that. Oops. And I also want to look at the entity Z layer. So we are going from 0 to 1. That's what I would have expected. We're doing a push sort barrier on here. So here's what I'm assuming is happening. I could be wrong. I'm assuming what's happening here is that because we're pushing from the top down, we're just getting the reverse order. So hopefully, if I'm right about that, we're actually doing everything correct. We're just getting the reverse order of the sort, right? I'm not sure, but I think that could be the explanation. because then when we pull through these things in the correct order, we're going to end up in a situation where we're always going to sort in exactly backwards. So let's see if we are sorting exactly backwards first, which I think we actually are. I guess there's really no way to tell. I can't go really up higher without seeing myself. So I think that's probably what's happening. I think we are sorting exactly backwards. Now that's not that hard to fix. There's a couple of different ways we could take a look at that. But one thing that might be the most interesting way to do that is just to change which one of these things goes in order. Because since we're only working with the sorting stuff now, it seems like maybe the best way to do it is just to say, well, when we push sort stuff on there, let's just make sure that our sort stuff always goes in order, and it's the other stuff that goes out of order, right? And that wouldn't be that hard. All we would really have to do there is say, well, okay, reverse the sense of these guys. So say, okay, we've got sort entries. So the sort entry at plus the size of a sort bound is going to be less than wherever the push buffer is currently at, right? I could do something like that. So then we would just have the push buffer at kind of go down, the sort entry at would go up, something like that, right? And that seems pretty fair to me. And because this is kind of fiddly, maybe now is a good time to kind of make these things a little bit more rigorous anyway. Excuse me. My throat's kind of giving out today. All right, how much time do I have left? I've got 17 minutes, 18 minutes, something like that. I think it's 18 minutes. Yeah. Anyway, so what I want to do here is just say, like, okay, we've got some understandings about where these things are, and they're kind of baked into the render commands. So, inside the platform thing, we've got this notion kind of in here of how this stuff is sort of a little bit finicky. So we have the push buffer size and the push buffer base, and then we have the max push buffer size. And then in here we've kind of got the sort entry at and the push buffer element count and all these sorts of things. And I think we probably just want to consolidate these a little bit here into something maybe a little bit more sane, right? Because it's a little bit tweaky at the moment. So what we really want to do is say, okay, we have a max push buffer size. That's definitely true. And then we have two sort of separate things. We have like a sort entry count, and we don't really need a sort entry at. We could really just use the count and multiply it by the size because they're fixed size, so they just kind of go up. So we could just say we have a sort entry count and it goes up, right? Then we have just a push buffer at variable, which could start at the top and work its way downward as we go, and we wouldn't have one of these, right? And then we could have another thing, which is eventually, I don't know how we did this before. I guess it's in a render prep. So inside render prep, we could say we have sorted indices and sorted index count. That would get us out of the business of having the push buffer element count be something that's used that gets modified and used twice. So that would be good too. And push buffer size is not really relevant anymore. So we should be able to get away with just this, I think. Well, I guess push buffer base, and this is like data at. I think that's a little clearer conceptualization of what we've got here. So similarly in there, now we know a couple things. Now we know we can sort of make a couple inlines here. For example, we could say sort sprite bound, get first sort sprite bound or something like that. We could have something like this, and when we pass that in game render commands, and what we would do there is just return whatever the push buffer base is. Yeah. So that would be get the first sort sprite bound. And similarly, we could, well, I think that's about it. It's the only real thing that we probably need. So then when we come up here and we say we want to do a push sort barrier, what we can do there is say, well, let's go ahead and assert that we're not going to move past where we should move past. So we can sort of start with this. And I guess I could call this get sprite, oops. Don't know what I accidentally hit there. We could call this get sprite bounds. And so when I get the sprite bounds, I now have like a basis of an array that I can use. And I can say, well, if, you know, the sprite bounds plus however many I have to go, so commands sort entry count. If I take a look at that, and it's less, I guess I should say +1. And it's less than whatever the push buffer data at pointer is, then it's okay. It's okay for us to go, right? And so assuming that it actually is, I would just say like commands sort entry count plus, you know, sort sprite bound, bound equals sprite bounds plus this. So that's an add bound call, basically, inline sort sprite bound, push bound. And honestly, I could probably do this a little bit cleverer. I don't know. You know what? I'm not going to do it that way. I'm just going to do it in line. So I go ahead and get one of the bounds out, and then I don't need to do that anymore, and I don't need to do that anymore. And so then I just say, like, OK, there's the bound, and we're done. Right? Same thing would happen over here. So we know what the size is, and now we just have to say, like, OK, let's get the sprite bounds out again, since we know we need those. And now we just say, OK, if the sprite bounds, and you know what, I'm going to cast this to a U8 star as well, because I kind of want to do a pointer compare here. And sometimes it's not safe to do pointer compares that aren't U8s. Compiler oftentimes will do stupid things in the name of optimization. So I want to go ahead and do the exact same thing here. So I'm going to do the exact same comparison. The only difference now is instead of comparing the push buffer data at regular, I'm going to subtract that size. So I'm going to assume that I did both pushes at once. If I did do both pushes at once, then I'm going to go ahead and do the actual operation here. So I'm going to do a minus equal of the size, so the push buffer data at moves backwards. And then the header doesn't actually need to do this part at all. It's just going to be at the push buffer data at value. We then do everything else that we would normally do. When we come down to the sort sprite bounds, that again is just the same push we did up here. It looks like that, and then off we go. We don't need to do any of these. Oops, we don't need to do any of these, and I think we're done. So at that point, we do have the aggregate bound stuff that we have to clean up a little bit. And the aggregate bound stuff, I guess we don't need to do anything with here, but just the begin and end part of things have to be done a little bit differently. So when we do a begin aggregate sort key, and we're doing this, the first aggregate at is going to be a little bit different. We're not going to do sort entry at, we're not going to do any of this. What we have to do is get sprite bounds for the commands, and whatever the current count is, that's where we want to be. Right? And then when we go to the end aggregate sort key, we come through here and we're like, OK, let's get the commands. We want to get the first entry, and the way that we would do that is exactly the same way. In fact, I guess now that I think about it, if these things are being pushed in order, how did we want to do this exactly? We're at first aggregate at. We wanted to start with whoever our first aggregate was. So yeah, so this is just going to be I think literally just that. What is first aggregate at? Is that just a value? I guess so. I guess it's really just this. I think that's what we actually want. So then we would say, like, okay, we've got a render group, sprite bounds. Right, so our first aggregate, we start there. We go through however many we had, and that's getting incremented all the time, I guess. I don't know that we really need to count this anymore. I'm not even sure why we were counting it in the first place, to be completely honest with you. It doesn't make a whole lot of sense to me why we would need to count that. It seems like aggregate count is unnecessary. It seems like all we really need to do there is say, well, okay, when we're done, we know what the aggregate count is. The aggregate count is just whatever the count is now, minus whatever the count was then. Right? So it seems like that's a saner way to do that. We then got some stuffs to do. All right, so let's take a look. Get sort entries is now, I guess that was actually the call that we had before. So we could actually call it get sort entries if we wanted to. In fact, maybe I should just do that. So we call this get sort entries, like so. And we'll just leave it at that. Because that's really what they are anyway. One more, should be. There it is. All right. So if the U in 8 star sprite bounds, blah, 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 so that's missing one of those. I don't know why I had an extra one, who nobody knows. And let's see, push buffer size. So the offset in this case is a little bit of pointer arithmetic. So we've got our push buffer data at, and it's really just whatever the max push buffer size is. So it would be, the offset is the max push buffer size minus however far we've gone so far. And I could just track that value directly. I'm not sure. Really, we're doing some bunch of 64-bit arithmetic here when we really could just be doing 32-bit arithmetic. Doesn't really matter, but it is worth noting. Anyway, so let's see. Commands push buffer size, U32. Group aggregate count equals 0. So in this case, all we really need to know is the first aggregate at, does that equal the current sort? Current sort count here minus 1, right? Meaning is the one that we just added, is that the first one? Let's see, gotta get those commands up to the right part. There we go. Okay, so for pushing a clip rect on, it looks like the pushing the clip rect on is basically the same operation as we have above. I'm gonna think about whether I want to abstract that at all. Let me see what else we've got here. Sort entry count is just now sort entry count, like so. Oh, except it's not. So sort entry count is actually prep sorted index count. What did I call that? Oh, I did call it sorted index count. I would like you to please get out of my way. I can't see when Handmade Heroes little banner is up on there. Go away, 5-minute warning. I know I only have 5 minutes left. Thank you. You have told me. Fade away, please. Fade away. All right, fine. Don't fade away. All right, so what's the problem here? Push buffer element count, when we're doing the global show sort groups, That's going to loop through those. Okay, so that's really, again, probably just going to be the prep group there, because that's, we really want these. I think that was kind of a little bit wrong before, but it's prep. Yeah, it's prep sorted indices. Oh well, no, it's because it's drawing the sprite bounds directly. So it's sort entry count and get sort entries. And where we go through here, presumably we also want to make sure that it's not equal to the sprite barrier offset value. We don't want to draw that. All right. Let's see. The push buffer element count is not a member of game render commands. Really? And in this case, again, it's going to be prep sorted index count. And I probably could just go ahead and put that in here. All right. For sort entries, this is just sort entry count. And now up here where we do push buffer element count, what I really want to do is I really want to write to prep. So really what we want to do here, let me go ahead and see where that prep is. So here's prep for render. And I believe prep for render, yeah, it goes ahead and does sort of the sort entries bit here where it puts the sorted indices in here. But I think what I would rather do is I'd rather just pass that along and have it fill it out itself, because it really needs to fill out both of those things, right? So what actually has to happen in here is it has to say like, oh, okay, game render prep. In here we would say, you know, prep sorted indices equals result, prep sorted index count equals whatever it equals. Right, just a little bit cleaner. Okay. So getting down to the last ones here, render command struct, we got, what are we doing? Initializing current initializer list to U8. Yeah, I see. So render command struct, we just have to kind of clean this up a little bit. We've got the width, the height, the max push buffer size. The sort entry count is still correct. The push buffer base is also correct. But now before we get into the other things, we then have to kind of say, well, the push buffer plus the max push buffer size is actually where we would start pushing data. So that's got to look like that. And then I think we're pretty much good to go. And it does look like that's true. All right. All right, so pushing clip recs on, push buffer data at minus the size. In this case, we just want to know whether that is going to violate our size. So we have our sort entries for this command set, and we're just going to add how many there are. And I think that's about it. So then we would just say push buffer data at we're going to go down by however much we need, and then we're just going to use it like so. All right, so that should probably crash and burn because I didn't get a chance to actually go back through it and make sure that it all works right. So that's a bit of a problem. I hate to leave it in that state, but it is almost time for the Q&A. I'm going to take a brief look at it just to double check here. But yeah, we will see. Anyway, oh dear. That's an interesting current clip rect value, to say the very least. Where does that value come from, by the way? That should be from platform.h, shouldn't it? Oh no, it's probably from render group. There's current clip rect. Okay, so let's do one quick thing here. I just want to do a couple of things while they're fresh on my mind, and then I can leave it and we can debug it tomorrow. So yeah, when I'm doing this, I kind of want this stuff to be a little more systemic. I don't like how it's duplicated in all these places, right? So what I would like to do is something like a, inline, maybe there's like a struct push buffer result or something. And the push buffer result will have a sprite bound, sort entry, and a void star for the data, or a header, I guess. Yeah, and I think what I'd like to do there is make it so that that operation is sort of some kind of coherent operation where you're like push buffer. You give it the render group. And it does the operation that you were going to do. So in this operation, I would say, okay, you're going to push the push buffer. You go ahead and start assuming you didn't get it. We figure out whatever the size is. So we say like, oh, the sort entry count that you're trying to push and the data size, right? So then we say, okay, if we want to figure out where that is, we figure out where the sprite bounds are. We say however many there are right now, plus however many you were trying to add, is where that pointer is going to be. The push buffer data at minus whatever the size is that you were trying to push for data, that's where that's going to be. And as long as they didn't cross, then we're okay. We would then update by the data size, and that header would be our result, wherever that is, right? Like so. And that's all we would do. Then similarly, to get the entry, it would just be that, wherever we were. And then we would go ahead and increment the sort entry count by however many sort entries we were trying to have, right? So that way, we can just do this much more cleanly and know that everyone's using the same code. We can just say that, there's a push. The push equals push buffer, render group. What did you want? I wanted one sort group and no data. So that's what I asked for. And then I just go ahead and, if I got it, I set it up. Make sense? And so then similarly here, we would do exactly the same thing. Also, this, I guess, doesn't even need to have that anymore. So here's exactly the same thing. I would say, oh, okay, I want to push. I know I want to push one sort entry and this amount of size on. I can get rid of these. I think well, I'm going to need at least one of those. But then assuming that I got it, I'll go ahead and say, all right, we know where the header is. The header comes from here. Everything else happens exactly the same. We know where the sprite bound is. Sprite bound comes from here. Everything else happens the same. And then I think we're done. Right? And then finally, there's the clear, or whatever it was, the push clear, push clip rect. That's what it was, push clip rect. So for push clip rect, again, I can do exactly the same thing. So this one's the opposite. It has actual size to push, but it doesn't. It wants to push size but no data. I'm sorry, it wants to push data but no sort entry because the clip recs don't get sorted. So all we have to do is say, okay, assuming that you've got a sort entry from the push, whatever it is. Oh, not a sort entry, sorry. Assuming you got data from the push, off you go. And I think I actually called that header. There we go. All right. All right, so I'm going to leave that and go to a brief Q&A. I just wanted to make that, oops. But then we're going to have to debug this tomorrow because this is going to crash. Because we didn't actually fix any bugs. I just want it to be a little bit cleaner, if that makes sense. Ooh, that's interesting. We actually got a null there, though. Maybe I'll take a look. Ah. Missed an assignment. So actually, that is supposed to be result.sort entry. And that looks good. All right. So off we go. And presumably we'll crash the same place. We do. And so then what we just have to do tomorrow is figure out why we're getting a header crash. Of course, you guys all get to debug this on your own. But what are you going to do? So, all right. Now I'll actually do the Q&A for reals. Sorry for the false teasing Q&A. Now we can go to the actual Q&A and talk about it some more. No questions. No questions. Meet George Judson. That clip rec count is so bizarre. I would have expected, if it was some memory trouncing there, I would have expected that to be a little different. No Qs. So it's just like bogus right off the bat. Right off that bat. Someone want to tell me why? Aha! That's why. That's why right there. Because this is initialized to a bogus value. So this clip rec count. So we have the width, the height, the max push buffer size, the 0, the push buffer, and data at. We've got the clear, the last manual sort key, and there we go. So that was that problem. To render into clip, what? There we go. And these should all be initialized to 0 anyway. I don't even know why those are all there. There we go. You mentioned earlier that the compiler would optimize the code, making pointer comparison unsafe. When does that happen? Thanks for the stream. So I didn't spend a lot of time looking at whether that was actually a case where that would happen. But here's sort of the idea. So let's say that we have a block of memory. And so I think I'm going to tell you the case where it does mess up. Thinking about the case that I actually did, I don't think it would ever mess that up. But I don't know. I never would put one past the compilers. So there's a thing that's basically, I don't remember the term they use in the spec, but there's basically like a memory region or allocation or something that they talk about in the C specification, which basically says that, let's say I have a pointer to a type, okay? So I've got, a type, and maybe that type is, 12 bytes. If I then have a type star A and a type star B, and I talk about these two types to the compiler in some arithmetic way. So I say, hey, I would like you to compute A minus B. Because of the spec and the people who wrote it, who I always pretty much disagree with, the default assumption for the compiler is that these two things are aligned to each other. So that means that A and B are an even multiple of 12 bytes away from each other. Always. Right? This one can't be 13 bytes away from this one or something like that. Even though that would be totally valid, that's not allowed. Because what the spec says is that any two pointers that you do arithmetic between are assumed to come in a contiguous array where they could each be numbered as a slot, right? So it's basically like, okay, you know, if A was here and B was here, then we assume this is 12 bytes, this is 12 bytes, this is 12 bytes, this is 12 bytes, and 12 bytes, right? B cannot appear here. It's simply not allowed, right? So rather than A minus B being U8 star A minus U8 star B, divided by size of star A, this is what you might expect, right? You might expect to take the difference of the pointers, the actual numeric values, and then divide by however big the thing was that they were pointing to. That is not what actually happens. The compiler is free to do all sorts of arithmetic nonsense that it wants to, where it assumes what these pointers actually point to and what their base values are, and so you have to be careful. So by force of habit and having been burned by compiler awesomeness like this in the past, what I generally do is when I have a buffer like this, where I'm sticking things into the buffer, you know, even if they happen to all be aligned properly, I will often convert to U8 stars before I do any kind of pointer arithmetic with them, because I'm not confident the compiler won't have some weird spec thing it can do to mess me up. Does that make sense? Hopefully that makes sense. All right. So I think we're done for today. It is 6:30. So I will be back tomorrow to finish that up. For the time being, we're going to have to leave it in a crashy state. I don't think it'll be very hard to debug this. So anyone who wants to do that for homework, go right ahead. But I probably won't look at the forums till tomorrow because I usually like to debug it myself on stream. And this is going to be, I think, not a particularly hard one. But if you want a little extra homework to do, download the source code tonight and see if you can find it. Because you should be able to just step through and watch what's happening with the pointers now and validate that everything gets put where it's supposed to be put. And at some point, you should find something that does not get put where it needs to get put. So that's up to you. All right. That's about it. I am going to wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code, so you can follow along at home. We also have a forum site if you want to... Whoa. Thank you, drawing tablet. We also have a forum site if you want to ask questions. You can go there and post them. We have a Patreon page if you want to support the video series, a schedule bot that tells you when we're going to be live, and an episode guide if you want to catch up on old episodes. That is it for today. I will be back here tomorrow at 5 p.m. Pacific Daylight Time to show wherever that bug is. We will find it, and then we will finish our sort. That's about it. Hope you have fun coding till then, and I will see you guys on the internet. Take it easy, everyone.